Greetings and good day, everyone. I am Keziah Brown, a senior psychology major, public health minor at Clark Atlanta University. I had the pleasure and privilege of spending the summer working on nutrition and obesity research at the Sealy Lab as part of the INSPIRE program. So, kind of our origin for our hypothesis was looking at human data. Oh, wow, this is good. Looking at human data and just looking at how the FGF19 levels are reduced in subjects with obesity and how a diet might how changing a diet might affect these levels in that gene. So, what we wanted to see was if the FGF15, So FGF15 is the gene that is the FGF19 in mice. It's just the regulator for bile acid. Just so you guys are confused, I'm going to use those maybe interchangeably. But just know 15 is mice, 19 is human. So we wanted to know if that gene was in fact necessary for cholesterol to bile acid conversion. Because if it is, we were thinking its removal might negatively affect the process, causing the mice to kind of get more obese after changing a diet, or kind of impact susceptibility to disease through the cholesterol levels. So we split the mice into two groups. How do you do that? Okay, got it. Split the mice into two groups, and group here is just the control, regular gene for a mouse, and then the other one is the FGF15 gene. It was knocked out of them. So for 12 weeks, they were on a high-fat diet, and then after the 12 weeks, half of each cohort was given a keto diet, and that's kind of where you start seeing these numbers. So just look at the pinks. So we can see, like, as they're eating the diet, the body weight is steadily increasing, and then after they were split, the body weight continued to increase in both the mice that had the FGF15 gene and the mice that did not. So we can't really say that weight was impacted too much with the gene removal, but just walk with me and we'll keep going further. So right now, under ketogenic feeding, just with the data we currently have, it's unknown if FGF19 levels or FGF15 levels change, just because those results are still needing to be ran. The mice are still alive, and unfortunately they have to be sacked to get all of that. So what we did get was the presence of FGF15 is necessary for cholesterol to bile acid conversion, but there was little impact on weight. But this is still promising because it leaves room for more interest in the plasma bile acid, and cholesterol levels, to see if the absence will impact their levels. So after literature searches were done, we kind of realized that this question of how does keto affect the FGF15-19 levels has never been asked before. So what you guys are looking at is really cutting edge for this. And this is significant to note because back to humans, the FGF19 genes could potentially be used as a biomarker. So whenever you go to your doctor, and this is why we say consult your doctor before you make any changes, to say, hey, I want to go on keto diet. Do you think it works for me? Maybe before you have to go through the process of going on keto diet and having your cholesterol levels increase or just have adverse effects, you can just get your blood tested for FGF19, and just depending on the results, it'll be determined on whether you'll be advised or not advised to go on a keto diet. So thank you, and that's my presentation. Any questions, comments, or anything? I hope so, because this is pretty cool. Me. Yes? Someone online? Okay. In the room? Yes.
So I actually don't have a question, I just have a compliment. This is really, really well done. And
Thank you. Thank
you're
you.
welcome. And the way you described it, I think it has a lot of relevance to how we think about this concept of precision health.
Absolutely.
Precision nutrition. Do you want to say more about that? I mean, your final statements were like crystallized perfectly. Yeah.
Thank you. So as far as I'm a big fan of bioindividuality. So it's just emphasizing that not everything works for each person. So with this, it's just acknowledging, oh, like if you have this gene or if you don't have this gene, like knowing what will work for your body before you kind of have to go through the processes and deal with the aftermath of having adverse effects to keto. Because that, I don't know if you guys have ever been or known anyone with ketoacidosis, but that is a very hard thing to go through. I've been through it myself. It is not easy. So yeah, just having this would be very, very useful. Yes.
Hey, great
Hey.
job. Thank you. I just wanted to ask, since I know the intended like application of this is kind of to apply it to human, human diets. So I was just gonna ask, like, how well do you think this is going to translate into human biology?
So being that the mouse is actually the most genetically similar to humans, it's going to be pretty close in translation, but there might be a few just offsets, and I would attribute that to, you know, environment, your specific genes in your family and things like that.
Thank you.
You're welcome. Anything else? Okay, thank you guys so much.